Welcome to the aluminum recycling process. From old beer cans, full of drama today. Right from the beginning, the footage captures the dramatic moment when tons of waste cans are poured into the furnace. Two men work together to lift a giant sack to feed the raw material. We see various Coca-Cola cans and Pepsi cans mixed randomly together. In that corner, a worker is meticulously, manually sorting the scrap. Crushed aluminum cans are scattered all over the ground waiting to be collected. After weighing and measuring, the sacks are dragged to the work area. The worker opens the sack to do a final check of the cans inside. The sack contains a mixture of many different beverage brands. The pull tabs on the cans are still intact, even though the bodies are crushed. There are green and blue cans, clearly visible. The vibrant colors of the can bodies create a striking highlight. Before entering the fiery furnace, the worker begins picking up handfuls and throwing them into the furnace mouth. This action is repeated until all the material in the sack is gone. Once the metal hits the bottom of the furnace, the high temperature makes them sizzle loudly. Thick black smoke starts rising from the paint coating on the outside. Next, a sack containing light yellow bottle caps is opened. These are the tops of beer cans, separated from the aluminum bodies. They are mixed into the general scrap stream to be melted down. Even thin foil packaging is thrown straight into the fire. Cigarette foil wrappers or aluminum foil are the second best source of aluminum. Dozens of discarded blister packs are also piled up in this industrial waste pile. Two workers coordinate to lift a large fabric sack off the floor. This requires skill to avoid spilling the metal. They lean their backs against the brick wall blackened by soot. The entire pile of scrap is now piled up to the rim of the melting pit. The fire hasn't fully caught yet, but the burning smell has already spread throughout the workshop. Thick white smoke engulfs the entire cramped workspace. A little residual grease is enough to cause small explosions. The ink printed on the can bodies starts peeling and burning fiercely. Bright orange-red flames begin to creep into the gaps between the cans. The temperature at the center of the pit is rising very rapidly now. The smoke cloud becomes so dense it obscures the worker's vision. Suddenly a huge column of fire erupts sky high. The roaring sound of the blaze echoes in the enclosed space. A worker holding a long iron rod approaches to adjust the flames. He forcefully pushes the burning scrap deeper into the pit. A dark green sack is thrown straight into the glowing pile. Immediately, the flames engulf the newly added material. A standing fan next to it helps supply oxygen to the fire. The worker continues checking around the edge of the pit to ensure safety. Whole aluminum cans are still waiting for their moment to melt. He crouches down to scrape away excess waste pieces. The iron shovel scrapes clean the slag stuck to the concrete walls. The fire has now calmed down a bit. After burning off the plastic, black dust floats in the air, making the workspace stifling and hard to breathe. The worker continues turning the iron rod to flip the scrap pile over, helping the heat penetrate deep into the core of each hard aluminum can. The fire dies in one spot only to flare up in another continuously. Plastic pieces start melting and sticking to the metal surface. Now he adds mineral salt to the surface of the hot liquid. White powder is evenly sprinkled across the molten pool to remove impurities. He scoops the salt with his hand and throws it forcefully to help it dissolve faster. Toxic gases and dust begin to separate from the molten aluminum. Using a long rod, he stirs vigorously to mix everything evenly. Bubbles rising to the surface indicate the chemical reaction taking place. This job requires patience, waiting until it reaches the right standard. At this point, the bottom of the furnace clearly reveals a pool of shiny molten metal. The blinding, bright light from the extreme temperature shines through the gaps. The brilliant orange color signals that the temperature is high enough for complete melting. The worker uses a ladle to test the fluidity of the aluminum. He adds a bit more refining chemical to increase purity. This mixture helps protect the aluminum from rapid oxidation. The flames die down completely, leaving only gray ash covering the surface. Under the slag lies the molten aluminum waiting to be cast. The iron rod is pushed deep down to feel the viscosity of the material. It slides smoothly through the gaps, proving the aluminum is completely liquid. The slag is pushed aside to make way for scooping the aluminum. The surface of the molten aluminum is as smooth as a mirror, reflecting the brilliant light. The worker steps back a bit to observe the whole batch. An iron stirring rod is placed at an angle to monitor the furnace temperature. Hot vapor rises and meets the cold air, creating a mysterious mist. Footsteps tread on the ground covered with aluminum scraps. The worker bends down to check the cleanliness of the casting area. The bottom of the furnace glows red as the slag is pushed aside. The large ladle is prepared to scoop the molten aluminum. The floor is swept clean. To ensure absolute safety, the empty molds are lined up, waiting for the pour. Wind blows through, stirring the fine dust on the mold racks. The worker, wearing a head wrap for dust protection and eye protection, slowly moves toward the furnace. The long stirring rod is used to skim off the final layer of slag. On the surface, the black slag is thrown far away to reveal the molten aluminum. Blinding red light radiates from the center of the aluminum melting pit. A ladle is dipped deep into the bottom to scoop up the liquid. The heavy block of metal is lifted out of the scorching pit. Excess aluminum solidified on the ladle is gently knocked off. The worker moves the full ladle of molten metal toward the row of molds. The molten aluminum is slowly poured into the first mold. Thick smoke rises as the aluminum touches the mold surface. He continuously moves to the next mold. To save time, each mold is filled carefully and precisely. Some molten metal overflows the edge and quickly solidifies. The pouring process is done quickly to prevent the aluminum from cooling too soon. When the ladle is empty, the pouring work immediately ends. First, we see the aluminum molds gradually cooling. After casting, shiny round aluminum ingots are revealed inside the stone molds. The worker is checking the hardness of the newly formed ingots. The staff use specialized tools to remove the aluminum ingots from the molds. The round aluminum ingots are removed and prepared for the next stage. Another worker is pouring molten metal into the arranged molds. The precision of filling the molds determines the size of the final product. The metal cools down quickly, forming solid aluminum ingots. The worker uses an iron rod to forcefully push the ingots out of the holders. The aluminum ingots fall onto the workshop floor, waiting to be collected. All operations are done manually, but very skillfully and rhythmically. The pile of aluminum ingots is swept together into a larger container. The large quantity of ingots obtained shows high efficiency. The worker uses a long stick to push all the ingots into one spot. The container is filled with pre-processed aluminum blocks. This is an important preparation step before remelting. Close-up shot shows the shiny surface of each aluminum ingot. The quality of the aluminum depends on the purity of the original raw material. The bin is full of carefully sorted aluminum parts. The worker moves the aluminum bin to the temporary storage area. Meanwhile, there are sacks of scrap that need further processing. The worker is picking up small aluminum scraps from the pile. Maximizing the use of raw materials significantly reduces production costs. Every old can and scrap is carefully collected. Sacks full of scrap will be transported to the crusher. The four main production areas with large industrial machines are operating. The blue hydraulic press is the heart of this production line. Workers bring sacks of aluminum ingots near the furnace to prepare for heating. Heavy aluminum blocks are tossed up to check uniformity. Two workers coordinate to load the material into the heating chamber. High temperature. The furnace glows red inside, making the aluminum malleable for pressing. The aluminum ingots are lined up inside the furnace's heat pipe. The orange glow from the furnace shows extremely high temperature is being maintained. The supervisor stands nearby to adjust the material feeding speed. The heating process must run continuously, without interruption. When the right temperature is reached, the aluminum is pushed out with extreme pressure. The giant hydraulic press starts to build pressure. The pressure gauge displays the energy consumed per batch. The operator controls the lever to manage the aluminum flow. Aluminum shavings stuck around the machine shaft are traces of the cutting process. The machine nozzle shapes the length and diameter of the aluminum wire. Hydraulic pressure pushes the glowing red aluminum block through the die. The outer layer of aluminum peels off due to high friction with the die. Long aluminum strands begin to emerge from the steel core of the machine. Stable speed ensures the wire has the best tensile strength. The aluminum wire surface is shiny even right after coming out of the furnace. The aluminum wire is guided through the pulley system to be evenly tensioned. Before winding, the white wire runs along the old brick wall of the workshop. The large spool starts rotating to take up the newly produced aluminum wire. The automatic winding mechanism helps package the product into neat coils. The guide system in front directs the wire position on the spool. Each motor rotation corresponds to one completed wire segment. The worker monitors the winding speed to prevent the wire from breaking. High concentration helps avoid unnecessary technical errors. The aluminum wire is tightly wound onto the metal shaft of the winder. The joint between two wire segments also needs careful handling. The guide wheels keep the wire on the desired path. The coil grows larger under the skilled control of the worker. When finished, the coil is removed and moved to the packaging area. A cart is used to transport the heavy aluminum coils. A worker uses a cloth to wipe dust off the surface of the finished coil. Two workers coordinate to lift the coil off the winder gently. The warehouse is already filled with shiny aluminum wire coils waiting for shipment. Overall, the quantity produced in one shift is very impressive. The coils are neatly stacked. In the warehouse, a worker is checking the tightness of each aluminum wire coil. The worker smiles while holding up two coils, proudly showing the results of his labor. The final product meets standards in both size and quality. Here, there is also a manual wire joining process to create continuous lengths. The worker brings a small coil to the workbench to assemble the equipment. Clamping tools secure the two wire ends before welding or twisting. Wire joining requires skilled hands and many years of experience. The joint must be strong to withstand pulling force during use. Pliers are used to tighten the connection between the two wires. Checking conductivity at the contact point. After completing the joint, the worker gently tugs the wire to ensure the joint doesn't come loose. The long wire is placed into the rotating cage to be coiled. Right after that, the conical metal frame helps prevent tangling and evenly distributes the wire. The electric motor activates, making the frame spin rapidly, collecting the wire. The aluminum wire sparkles silver as it spins at high speed. The entire amount of wire is collected into a single compartment. The winding machine operates smoothly despite the heavy load. Continuously, the mechanic adjusts the brake to wind the wire more tightly. The large coil is lifted off the machine base. For easy removal, the worker pushes the heavy coil down onto the safe ground. The next step is labeling to classify the goods. The finished products are loaded onto a cart to be moved to the exit. A highly efficient closed-loop process from scrap to finished aluminum wire. The winding frame is quickly replaced. To start a new batch, the machine restarts immediately. To avoid wasting downtime, the workers continue working diligently. In the dusty environment, the wire joints are neatly trimmed with hand tools. A worker uses pliers to bend the excess aluminum wire. Precision down to the millimeter determines the aesthetic quality of the product. The final coils are randomly inspected before shipment. The video ends with a huge pile of finished aluminum wire coils stacked high in the warehouse.